Hello guys, so for this video we are going to talk about homeostasis. So what is homeostasis? It is a condition of equilibrium or balance in the body's internal environment due to the constant interaction of the body's many regulatory processes. Do you ever think of 1 billion cells in your body? It needs certain condition for them to function properly. Homeostasis function is to regulate certain conditions, or variables in our body, because sometimes temperature can be too hot or too cold. Acid or fluids can also be too acidic or too alkaline. Homeostasis also maintains supply of things in our body such as glucose and water. Homeostasis is a dynamic condition. In response to changing conditions, the body's equilibrium can shift among points in a narrow range that is compatible with maintaining life. But before anything else, do you know who talked over the homeostasis? One of the first scientists to discuss the significance of homeostasis to the survival of an organism was French scientist Claude Bernard, 1813 to 1878. Homeostasis is essential on survival, hence, many of the body's systems are concerned with maintaining this internal environment. Here are some examples of homeostasis: blood sugar levels, body temperature, heart rate, and lastly is the fluid environment of cells. When homeostasis is maintained, our body will become healthy. This is the reason why your doctor takes the following examples that I've said earlier, as a part of routine examination. To continue, our body has many regulating systems that can usually bring the internal environment back into balance. Most often, the nervous system and the endocrine system, working together or independently, provide the needed corrective measures. To further explain, our nervous system regulates homeostasis by sending electrical signals known as nerve impulses or action potentials to organs that can counteract changes from the balanced state. While endocrine system includes many glands that secrete messenger molecules called hormones into the blood. Nerve impulses typically cause rapid changes, but hormones usually work more slowly. These body systems are both means of regulation. However, work toward the same end usually through negative feedback systems. Now, let's talk about the feedback systems. A feedback system, or feedback loop, is a cycle of events in which the status of a body condition is monitored, evaluated, changed, remonitored, re-evaluated, and so on. Each monitored variable such as body temperature, blood pressure, or blood glucose level, is termed as controlled condition. Any disruption that changes a controlled condition is called a stimulus. Let's move on to the three basic components of feedback system. The receptor, which detect the change. A receptor is a body structure that monitors changes in a controlled condition and sends input to the control center. Next component is the control center, which interpret that change which detected by receptor. Specifically, it is the brain that sets the range of values within which a controlled condition should be maintained, evaluates the input it receives from receptor, and generates output commands when they are needed. After interpretation of change, the command will be sent to the effector. It carry out the change. Effector is a body structure that receives output from the control center and produces a response or effect that changes the controlled condition. Can you imagine how it really works? I'm going to show you the operation of feedback system. It starts with the stimulus that disrupts homeostasis by increasing or decreasing a controlled condition that is being monitored by receptors that send nerve impulses, or chemical signals, that serves as an input to the control center, that receives the input and provides nerve impulses or chemical signal that serves as output and send it to effectors. Then it bring about a change, or response that alters the controlled condition. After it undergo to the different processes, it will return to homeostasis when the response brings the controlled quantity back to normal. Homeostasis has two different feedback systems. It is the negative feedback system and positive feedback system. Now what do you think is the main difference between negative and positive feedback system? To change the controlled condition in some way, either negating it, or known as negative feedback, or enhancing it, known as positive feedback. To explain more clearly, let's look for the meaning of negative feedback system. As what you have read, it reverses a change in a controlled condition. Best example of it is body's blood pressure. Let's see how it works within our body parts and organs. Negative feedback system within the body's blood pressure. If some internal or external stimulus causes blood pressure known as controlled condition to rise, the following sequence of events occurs. Baroreceptors serve as the receptors. Pressure-sensitive nerve cells located in the walls of certain blood vessels detect the higher pressure. The baroreceptors send nerve impulses or an input to the brain, as control center, which interprets the impulses, and responds by sending nerve impulses as an output to heart and blood vessels, which are the effectors. Heart rate decreases and blood vessels dilate widen, which cause BP to decrease, which known as response. This sequence of events quickly returns the controlled condition, blood pressure, to normal, and homeostasis is restored. Since we already know the negative feedback system, it is our time to study about the positive feedback system. Unlike a negative feedback system, a positive feedback system tends to strengthen or reinforce a change in one of the body's controlled conditions. In a positive feedback system, the response affects the controlled condition differently than in a negative feedback system. The control center still provides commands to an effector, but this time the effector produces a physiological response that adds to or reinforces the initial change in the controlled condition. The action of a positive feedback system continues until it is interrupted by some mechanism. Normal childbirth is an example of positive feedback. This is how the positive feedback system works within normal childbirth. The first contractions of labor as the stimulus push part of the fetus into the cervix, the lowest part of the uterus, which opens into the vagina. Monitor the amount of stretching of the cervix known as controlled condition. Stretch-sensitive nerve cells are known as receptors. As stretching increases, they send more nerve impulses or an input to the brain, which is the control center, which in turn releases the hormone oxytocin as an output into the blood. Oxytocin causes muscles in the wall of the uterus or an effector to contract even more forcefully. The contractions push the fetus down the uterus, which stretches the cervix even more, and this is what we call a response. Interruption of the cycle. The birth of the baby decreases stretching of the cervix, thus breaking the positive feedback cycle. Increased stretching of the cervix causes the release of more oxytocin, which results in more stretching of the cervix, and this is what called a positive feedback. As a summary, as long as all of the body's controlled conditions remain within certain narrow limits, body cells function efficiently, homeostasis is maintained. Therefore, our body will remain healthy. Hope you learned in this video. Thanks for watching.